Permutations is another counting technique that we can apply to count items or count objects. And permutations are going to specifically apply when we are looking at an arrangement of items. Okay? And for this specific formula here, we're going to look at an arrangement of R of n items in some kind of order. Okay? And this order is going to be even more important a little bit later when we learn about combinations. Okay? So what this means is we want to take a set of n objects, select any R of them, and put them into some kind of order. Okay? So for example, let's say there are 30 students in a classroom. We want to pick 10 of the students out of those 30 and arrange them in order in a line. Okay? That would be an arrangement of 10 of the 30 students in a definite order. Okay? That would apply for this permutation, for this permutation notation. So what a permutation will allow us to do is find out in how many different ways could we possibly arrange those R items taken from the N. Okay? And the formula for that is going to, and the formula and the notation for that is going to look something like this. First of all, the actual notation for a permutation, it's going to have a P, and then it has two subscripts, one on either side. So it's going to be N on this side and R on this side. And you might actually notice that you have a button on your calculator that relates to this as well. Or if you don't have a button, it might be in a menu somewhere on your calculator. So this notation, we can read it as NPR, or the more official way to read this would be a permutation of R items taken from N items. And this formula for permutations is going to use the idea of factorials. So this formula is going to be n factorial over n minus r factorial. And the details behind this formula, we'll talk about that in class because that's a little bit more complex than what can go in a video here. So we'll talk in class about why this formula is n factorial divided by n minus r factorial. But just to get used to working with this notation here, let's do a few calculations using permutations. So let's do something like 12p3. So what this means is we have 12 objects to start with, and we want to choose any 3 of them and put them in some kind of order. So whether it's in a lineup or whatever. Okay, so 3 items chosen from 12, and we want to put them in a specific order. Okay. Well, using this formula, that would mean we have n factorial, so that would be 12 factorial, because the 12 matches up with the n here. Okay, then divided by n minus r in brackets with factorial. So n minus r is 12 minus 3, and then we've got the factorial. Okay, so using what we know about factorials, well, this is the same as 12 factorial over 9 factorial. Okay? And if we write this in expanded form, that tells us that we've got 12 times 11 times 10 times 9 times all the way down to 1 over 9 times 8 times, and then again all the way down to 1. The numbers from 9 and down to 1 will divide out with the denominator, and we're going to be left here with 12 times 11 times 10, okay, which is 1,320. Another way we can look at this same problem is to draw a little bit of a diagram. So we want to take from 12 objects, we want to take 3 of them and put them into a specific order. So these are the 3 positions that we want to place those objects in. Okay? So we have our 3 spaces here that we're going to put our 3 objects in. For the first object, okay, or for the first space, we've got 12 different options of what object to place there because we're choosing these 3 items from the 12. Okay? Once we've placed an item in that first slot, then for the second spot, we've got 11 options now because we've got one less than we had before. We've already placed one of the objects, so now we've only got 11 left to choose from. We've got 11 options for what we could pick for the second spot. Okay? For the third spot, we've got 10 options because we've now used up the first 2 items. So now there's only 10 left to choose from. So we've got 10 options left for the third spot. If we multiply these 3 numbers, we're going to get the same number that we got down here, 1,320.